section is we're measuring TDS, which is called total dissolved solids in the water, and we're also measuring hardness. So, so when I say total dissolved solids, does anybody know what dissolved means?
Oh, where it was once like a solid and then it kind of just, its particles kind of just split and kind of mix in with the water.
Yeah, so it's any sort of substance that it's still solid, but it mixes in so well with the water that you can't see it anymore. An example would be salt or sugar. Like anytime you mix those into water really well, you can't see it anymore. So those are the kinds of things we're measuring in the water, the stuff we can't see. Some examples of the stuff we're measuring are stuff like calcium. You guys know what calcium is good for? What?
It's like bone marrow. It's good for you.
It's good for your bones.
It grows your bones.
Yeah, you need it for your
Makes
bones.
it hard.
And we're also measuring stuff like nitrates and phosphates, which are really important for plant life. Plants can't live without those. So TDS is measured in parts per million. Did you guys go over parts per million?
No. No, we didn't, but we have it on there. Yes.
On there. Okay, so we can go over it. So for parts per million, to give you an idea of what a million looks like, so you can kind of get an idea of the scale. Yeah, well, so this is a football field that has, or a stadium that has 100,000 people in one stadium, so 100,000 people. So how many stadiums do you think you would need to get a million? You would need 10 stadiums to get a million people. Now, to get an idea of parts per million, let's pretend each person represents a molecule. They're either going to represent water or they're going to represent sugar. So if we had 10 parts per million, that would mean only one person in each stadium represents water, or no, sugar, represents sugar, and the rest represent water.
It's only 10 people from each stadium.
One person from each stadium. So that would be 10 people
sugar.
together. Yeah, it would represent sugar, and the rest represent water. So you get almost a million people representing water, and only 10 representing sugar. So it's a really, really small amount. So that's what we're going to be measuring. So I need 2 volunteers to go down and get water. Wow, you all. Who hasn't gone to get water?
Troy, you have.
All right. You two. So if you'll go fill this one up to the black line, and you guys can go like right over there. And I need you. See how it says 25 milliliters?
Yes.
Okay, I need you to fill it up to that line, and you can use this for small adjustments.
Go with.
Does anybody have any ideas where the dissolved solids come from?
Mountains.
Snow.
Mountains.
Mineral, like off rock.
It's mainly off of rocks. Yeah. So yeah, most minerals are made up of the stuff we're measuring.
But isn't snow kind of like that because it has to melt?
Snow. So yeah, it has the water. So snow provides the water usually, and then the water will rush over the rocks and it'll dissolve the rocks, and that's where you get your minerals. Okay, so to measure total dissolved solids, we use this.
Can I do it?
So yeah, sure.
Austin wants to do it.
So water, when there's certain chemicals in it that have a charge. Troy.
What do you mean when it has a charge?
Like they have positive and negative qualities, and when you have them in water, they can create an electrical current or a charge, and that's what we're going to be measuring. So the more TDS you have, the more charge you should get, so the higher the reading. And
So turn it on?
So you can turn it on and then just stick it in the water and let us know what number you get. 20, okay. So that's our meter reading, which should be your first question. And then I need somebody to multiply.
You want me to clean it?
No, you can just turn it off and set it
Multiply
down.
what?
So do 25 equals 13. Okay, so that's our actual reading. So that should be your second question. So there's only 13 parts per million of TDS. So to tell if that's good quality water or bad quality, or low TDS or high TDS, here's a table.
That's good.
So these are different types of water, and here is their typical TDS reading. So if you can see, distilled water usually only has 0.5 or 1.5 parts per million. But if you go all the way up to water that's harmful to pipes, it usually has anything greater than 500 parts per million. So usually we're working within ranges from 0 to 500 parts per million. So where would our number be on this?
Rainwater.
It's closest to the rainwater. So we have low TDS here. It's actually okay for us because we generally have anywhere from 20 to 30 parts per million. So we're actually doing okay. Do you have any other questions for TDS?
Where do dissolved minerals in the creek water come from?
So did we figure out where the dissolved minerals come from?
Rocks.
They come from rocks and mountains. Okay. So our other test is for water hardness. Has anybody heard of hard water before?
Yes.
Yes.
Do you know how you can tell?
When it comes out of your shower head, it makes it like white.
Yeah, it's all white.
It's how much acid. Isn't it how much acid it has in it?
That's a good guess. It's actually a measure of how much calcium and how much magnesium is in it. So hard water will cause all that. And we're going to measure for it using a titration. So if you guys will put your goggles on. So we're going to be looking for a color change. First we're going to add pink color to the water. First, let's see. Christian?
Yes.
Okay, so would you like to add 10 drops of this to it? So I want you to hold it completely up and down. And then if you guys want to help count the number of drops, that'd be helpful.
2, 3, 4, 5, 6, 7, 8, 9, 10.
Perfect. Okay, and then you can pass it to
Christian.
Isabel. So you're going to be adding 5 drops of the pink. So make sure you hold it up and right, vertically.
1, 2, 3, 4, 5.
Ooh, you almost got
Okay, and then if you'll put the lid on.
I'm gonna shake it.
Could I shake it?
You
guys do everything.
Yeah, she can shake it.
You went to the river, so you shouldn't be.
So put your thumb over the top,
Yeah, true.
and then you have to shake it up.
Who's the person that has done that?
Let's see. Turn it. Okay, so if you guys can see, it's completely mixed in, and it's a nice Troy. It's a nice pink color. So if you can pass it to.
Pepto-Bismol.
So now what we're gonna do, we're gonna see how many drops of this it takes to turn the water from a nice pink color to a blue, and how many drops this takes.
It's already bluish. Yeah, it is. If you see it from here, it looks blue.
A little.
No, it's just
Well, then maybe it won't take that many drops, but we're gonna see how many drops it takes. So here you go.
Here, I'll hold it.
It feels weird when you see.
Just one drop, and then put it down. No, just one drop. Oh,
Don't it one.
oh here.
That was
Okay, so put the lid on.
wrong way.
She did 2 drops.
Yeah. Okay, so mix it up.
It big time.
Oh, she.
Okay, so it took
purple.
2 drops. Yeah, usually you do 1 drop at a time, and then you mix it up, and then you pass it.
Now it's blue. Now it's
So
blue.
it's blue. So it took 2 drops to make it blue. So 2 drops doesn't actually tell you how much in parts per million. To get parts per million, you take however many number of drops you had, and you multiply it by 10.
So is it 20?
It's 20. So we had 20 parts per million.
Which minerals was hardness test for? We forgot to do.
We'll go over it. So 20 parts per million. So to tell if that's hard water or soft water,
I got it 20.
you write down? Okay. So if you look here for our number, you'll see what kind of quality water we have. So what kind of water do we have?
Soft.
We have soft water. Okay, so what minerals were we just testing for in this test?
Calcium and I can't remember.
Alright, who wants to write?
Magnesium.
I can't write.